Dear students, in this lecture we discuss some simpler cases. So first is equations that do not contain x. So explicitly you will not find x in that equation. Okay, that means given DE has form f of y comma p equal to 0. So it contains y and p only. So we will have two cases. Either this equation 1 is solvable for p or solvable for y. Okay. So if 1 is solvable for p, then we can rearrange equation 1 as p equal to some function of y, say phi of y. And now p means dy by dx equal to phi of y. And now this can be dy divided by phi of y equal to dx, and this is separable form and it can be integrated and we get required solution. Okay, this is separable form and can be integrated. Another thing is, another case is equation 1 is solvable. Yeah, it is solvable for y. That means 1 can be written as y equal to some function of p, say capital F of p. We call this as 2. And now we proceed as in the case solvable for y. So what we do, we differentiate this equation with respect to x and write dy by dx as p, and we get differential equation in p. We solve that differential equation and then eliminate p from this solution and equation 1. Okay, so we differentiate this 2 with respect to x. So we get dy by dx equal to differentiation of right hand side with respect to x. So it will be f dash of p and dp by dx, and this left hand side dy by dx is nothing but p. So p equal to f dash of p into dp by dx. We solve this for p. We solve this differential equation for p, and then we eliminate p from this solution and 1. In some cases, it is not possible to eliminate p. In that case, uh, the solution of this differential equation in p and equation 1 form the required solution. Okay, so if it is not possible to eliminate p, then this solution and equation 1 form required solution. This is same as the case we studied earlier, that is solvable for y. Next particular case is equations that do not contain y, which is analogous to this case. So our differential equation is of the form, it is some function of x and p. We call this as 1. Again, we have two possibilities. First thing is it may be solvable for p. If 1 is solvable for p, it can be written as p as a function of x, because we have only two variables in these differential equations, namely p and x. So we have p equal to phi of x for some function phi. Okay, that is p is nothing but dy by dx. So dy by dx equal to phi of x, and we can easily write this as dy equal to phi of x dx, which is separable equation, and it can be integrated and the general solution is obtained. Okay, integration gives required solution. Another possibility is this equation is solvable for x. Okay, this equation 1 f of xp equal to 0 is solvable for x. If 1 is solvable for x, then it can be written as x equal to f of p for some function f. And now we have to proceed as we discussed earlier. Okay, if the equation is solvable for x, then we differentiate that equation with respect to y and then try to eliminate p. So differentiating with respect to y, then we differentiate with respect to y and proceed as discussed earlier. So let us solve some examples. Example 1, solve y equal to 2p plus 3p square. Okay, this equation does not contain x. This differential equation does not contain x. So of course we have two possibilities. We can solve this for p as well as for y. Okay, so we solve this example using both the methods. Okay, so method 1, so given equation is quadratic in p, we can find its root. Okay, from given differential equation, it is 3p square plus 2p minus y equal to 0. We have, so we have roots of quadratic equation p equal to minus 2 plus minus square root 2 square, that is 4, minus 4 times 3 into minus y. So plus 12y divided by 2 into 3. So we have this as minus 1 plus minus square root 1 plus 3y. We are cancelling 2 from numerator and denominator. Okay. So this is left hand side is p, means dy by dx. So we can convert it to separable equation. So we have dx, we multiply by dx so that we get dx equal to 3 divided by minus 1 plus minus square root 1 plus 3y dy. And we can integrate this. So we use substitution. 1 plus 3y equal to t. So that dy 3 dy equal to dt means dt equal to yeah, there is 3 dy. Okay, Further, we have, therefore right hand side is nothing but numerator is 3dy, so we can write dt divided by minus 1 plus minus root t. So let us take two cases. If we take plus sign, then dt divided by minus 1 plus root t, it can be written as 1 upon root t plus 1 upon root t into root t minus 1. This will be simpler to integrate. Okay. And we can have integration therefore integral dt by minus 1 plus root t will be integral of right hand side. It is integral of root t, so t raised to minus 1 by 2. So you can say that it is 2 times square root t plus log of root t minus 1. Of course, constant of integration will be there. So here we again back substitute 1 plus 3y for t and we get, okay, so we call this as star. Therefore by star we have left hand side is dx, integration gives x equal to 2 times square root 1 plus 3y plus log of square root 1 plus 3y minus 1 plus c, and using minus sign. Okay, so we have two equations, dx equal to 3 divided by minus 1 plus square root, and another is minus 1 minus square root. Okay, so second case gives and x equal to minus 2 into square root 1 plus 3y minus log of square root 1 plus 3y plus 1 plus c. Okay, so these are required solutions. Note that we will not have unique solution always. We can have a number of solutions. Okay. Now we use another way. So consider given differential equation. It is y equal to 2p plus 3p square. We can treat this as equation solvable for y. Okay, and proceed as we discussed. Given DE is solvable for y. Y equal to 2p plus 3p square is solvable for y. So what we do? We differentiate this with respect to x, differentiating 1 with respect to x. We get left hand side is dy by dx. It is p. Dy by dx is p. And right hand side is 2p. So it is 2 into dp by dx plus 3p square. So it is 3 into 2, that is 6p into dp by dx. We can simplify this. So it is right hand side is 2 plus 6p into dp by dx. So we can convert it to variable separable form. So it is dx equal to 2 plus 6p divided by p dp. Okay, and it is nothing but 2 divided by p plus 6 dp, and now we can integrate. Integrating, we get x equal to integration of 2 divided by p, it is 2 times log of p or log of p square plus 6p and plus constant of integration. We call this as 2. Okay, now it is not simple to eliminate p. So this 2 along with 1 form solution of given differential equation. Okay, so this is also another way. So 2 equation 2 along with 1 is required solution. In the notes, I have provided example for the second case, that is equation which do not contain y explicitly. Thank you.